Hello, everyone. Today we are going to be looking at ellipses a little bit more. We'll finish looking at our key features, and then finally we'll look at how we can graph an ellipse given an equation. So in the last video, we just looked at the geometric definition, and we didn't really work a lot with equations. To start off, I've drawn an ellipse and all of the key features that we identified in our previous video. We have the major or the longer axis, the minor axis, which is the shorter axis. We have the x and y radii, or the x radius, y radius, which are in the x and y direction. We have the foci, so we have we have a focus here and a focus here. So our two foci, and then we know that from our geometric definition for any point P on our ellipse, the sum of the distances from that point to each focus, in other words, d1 plus d2 is constant. So that's what we learned in our previous video. Today we'll finish up with taking a look at this constant and then also finding how we can find where the foci are for an ellipse. So to start off, an interesting observation is d1 plus d2 is not only constant, but it's also equal to the length of the major axis. And so in this case, because we have a horizontal ellipse, it's going to be equal to the length of the axis in the horizontal direction. And we know that the x radius is 1/2 of that. So it's going to equal to 2 times the x radius. If we called the x radius a, it would be 2 times a. So not only do we have a constant sum of values or sum of distances, but that sum of distances is equal to the length of our major axis. There's a pretty interesting way to see this, which you can see on page 473 of our book. I don't want to spend too much time going over these. But basically, it has to do with looking at a point here at the vertex and then looking at d1 and d2. All right, so we know that the sum of the distances is 2 times the x radius in this case, or the longer radius. I also want to go over how we can find these 2 points, f1 and f2. So how do we find the 2 foci? Really quickly, I want to talk about one more definition. The distance from the center to the focus is going to be our focal radius. So when we talk about focal radius, we're just talking about how far away the focus is from the center. And this is going to be the same on both sides. So this is also the focal radius from the center to a focus. If we call that focal radius c, then in order to find c, we can take c squared is equal to, and then we have a squared minus b squared. And so this equation comes from the Pythagorean theorem. There's a way to set it up in our ellipse to derive this equation. We're not going to go over how to find this equation though. C squared, so c is our focal radius. A and b are the 2 radii that we have. So a is the longer radius, and b is going to be the shorter radius. So we're taking the difference between the longer radius squared and the shorter radius squared. If we look at our example up here at the top, here the x radius is a. So in this example, we have our x radius as a. So we'll square whatever that is, and then we're subtracting the square of our y radius. And one way to note or to remember that this is our longer radius is when we square it and subtract the b squared, we want to end up with a positive number because we have c squared equals, and we're only working with real numbers here. So if you were to switch them, then you would get a negative number, which would tell you that you made a mistake when calculating the focal radius. Once we have c, all we have to do is look at the center and then add c in the x direction and subtract c in the x direction. So going c units to the right and c units to the left. And that's for a horizontal ellipse. If our ellipse was vertical, we would be adding in the y direction. So just think about moving this ellipse or rotating it 90 degrees. Okay, So those are our final notes about the key features of ellipses. Next, we're going to take a look at what an equation of an ellipse looks like and how we can use that equation to graph our ellipse. So for any ellipse, the equation of the ellipse is going to look like this. We have x minus h squared over rx squared plus y minus k squared over ry squared. So for any equation for an ellipse, the equation is going to look like this. We have x minus h squared over rx squared plus y minus k squared over ry squared. So really quickly, h and k represent the center of our ellipse. Rx is just the x radius. And then ry is the y radius. And our book writes x minus h over rx squared, which is equivalent. It's the same thing. Because we're squaring the rx, we could just put this whole thing in parentheses and square it too. So either one of these forms works. So if we're given an equation in this form, we can really quickly identify these key features and then graph our equation. So let's take a look at an example problem and then how we can graph given an equation of an ellipse. So here we have an example equation. We have x minus 1 squared over 4 plus y plus 4 squared over 9 is equal to 1. So starting off with our center is going to be h comma k, and we're subtracting h, so we have x minus 1. So h is 1, and then y plus 4, we can rewrite this as y minus negative 4. So the number we're subtracting is negative 4, or it's the opposite. So 1, negative 4 is our center here. For our x radius, we know that the x radius squared is 4. Our x squared equals 4. So we take the square root of both sides and get that our x radius is 2. For the y radius, same thing. The y radius squared is 9. So if we take the square root of both sides, we have 3 for the y radius. And when we take square roots, we usually have to watch out for positive and negative, but because we're looking at the radius, which is a distance, it's always going to be positive. So we're just looking at the positive of these square roots of 4 and 9. Okay, so now that we've identified these key features, we could start to graph our equation. I'm gonna pull up a graph and then we'll plot these features and finally end with finding each focus for our ellipse. So here we have a coordinate plane. We know our center is at 1, negative 4. So our center is gonna be down here. Technically our center isn't a part of our graph, but I'm marking it just to make it easier to sketch our graph. Our x radius is 2, so 2 to the right. We know this point is on our ellipse, 2 to the left. That point, 2 to the left, 1, 2, is also on our ellipse. And then the y radius is 3. So if we go up 3 and then down 3 from the center. So our ellipse is going to look something like this. Okay, so we've got most of our ellipse graphed. We might also be asked to find the foci. In other words, find F1 and F2, those 2 points. So here what we can do is look back at our equation here. C squared equals a squared minus b squared, where a is the longer radius and b is the shorter radius. So in this case, if we look at our 2 radii, 2 and 3, 3 is our longer radius. So we have 3 squared minus 2 squared, which is 9 minus 4, which is 5. So we know c squared is equal to 5, which means c, in other words, the focal radius, is square root of 5. So to find our 2 foci, what we would do is we would start at our center, and then we would go up by c, and also go down by c. And we're going up and down because we have a vertical ellipse in this case. So F1 is going to be somewhere around here. F2 is down here. And to write them out, we can just add and subtract from the y value of our center. So our center has an x value of 1, and then we have negative 4 plus root 5. So that's our first point here. Oops, sorry, that should be F1. So F1 is 1 comma negative 4 plus root 5, and we can just leave it because it's an irrational number. F2 is going to be same x value 1, and then we have -4 minus square root of 5. So this is how we can find the two foci for our ellipse. So in our next video, we'll look at what happens when we're given an equation, but it's not in this form. There's a way that we can manipulate or change our equation so that we can find these key features more easily.